Hello guys, so I would like us to look at this question. Use the substitution u is equal to x squared to show that the integral from 0 to 1 of this is equal to pi squared over 16. So I'm going to start off by substituting u with, where there's x squared, I put u. So solution, I'll have integral from 0 to 1 of x sine inverse of u, all this divided by 1 minus, this will be u squared integral. And what will be my dx here? Now let's evaluate it here. We've been told u is equal to x squared. So du dx will obviously be equal to 2x. So if we want to replace dx, our du over 2x will be equal to dx. So instead of dx, we will have du all this divided by 2x. This x can cancel out with that x, so that we simply have integral from 0 to 1 over sine inverse u, all this divided by 1 minus u squared du. We have over 2 here. Now I want to rearrange this so that we can clearly see how it turns out. This is integral from 0 to 1 of 1 over 1 minus u squared sine inverse u du. Can have their half out here. Now notice that if you differentiate sine inverse u, you get this function here. So this function is basically in the form f of x, and then this is f prime of x. If you differentiate this, you get this. So the best way to solve such functions is by using algebraic substitution. So what I'm going to do is I am going to let this, so let p be equal to sine inverse u. I've introduced a new variable p. Now if p is sine inverse u, then what is dp du? If we differentiate sine inverse u, we get 1 over 1 minus u squared square root. So I want to rewrite the whole of this question in terms of p. So it's going to be a half integral from 0 to 1 of 1 over 1 minus u squared. Instead of sine inverse u, I will have p. Then instead of du, I will replace du with, so make du the subject of the formula here. We will have 1 minus u squared square root and then dp. So this cancels with this, and we simply remain with integral from 0 to 1, there's a half out here, of p dp. Integrating p, we get a half p squared over 2. Now, integral is from 0 to 1. But remember, this range we were given was defined with respect to x. So I need to rewrite my answer back in terms of x. Now, what is p? P is sine inverse u. So this is going to be now a half divided by 2. That gives me a quarter. So instead of p squared, I will have sine inverse of u squared. Integral from 0 to 1. But this range is with respect to x. And what is where x? Remember, we said that we use the substitution u is equal to x squared. So where there's u, I'll put x squared. So this will give me a quarter sine inverse of x squared squared. Integral is from 0 to 1. Then let's now replace the ranges. So I have a quarter sine inverse of, I put 1 where there's x, 1 squared, minus a quarter sine inverse of 0 squared. Okay, and we have squared here. So this is x squared, and then the whole of this is also squared. And this is sine inverse of 0 squared, and then the whole of this is also squared. So evaluating that, what do we have? So what is sine inverse of 1 squared? Now sine inverse of 1 squared, if you do it to the calculator, you'll get that it is 90. So I can write it as a quarter sine inverse of 1 squared, that is 90, which is the same as pi over 2. And this is further squared, minus a quarter sine inverse of 0 is 0. So this gives me a quarter, and then pi squared over 4. So this gives me pi squared over 16. And we've been told to show that the integral of that is equal to pi squared over 16. So that's how we go about it.